chemical effects of electric current. Learning about electricity. We are facing so much of load shedding nowadays, and with the summer, it's really hot. It's almost time for the current to come back on. Electricity, as we all know, plays a very important role in our day-to-day life. Electricity is used for a varied number of purposes that makes our tasks easy. For example, we use electricity to light up our room, run our appliances, like the television and computer, the fan. In my great-grandfather's time, they did not have electricity the way we do. And so, they did not have the appliances that we are so used. No television, no fans, no street lamps, no motor pumps. Imagine having to live like that. Electricity has improved the way we live. We have lights and are able to go out even after it's dark. A lot of our industries work at night too. Imagine living in our great-grandparents' time, having to go to bed at 7 at night, or having to study with the help of a lantern. So where does the electricity to our homes come from? Electricity is produced at power stations. Power stations are also known as power plants. Big electric generators at power station produce electricity with the help of water or coal or even nuclear power. The electricity is brought to our homes through thick cables or wires that are either fixed on the electric poles or through underground cables. Caution! Electricity is extremely useful, but as it is with all the things, we must learn to respect electricity and use proper methods of handling electricity. If we use our appliances carelessly, like pulling a plug out of the socket without turning off the switch, or handle the plug with wet hands, we are likely to get an electric shock. Some electric shocks cause severe burns and even death. This is a caution or danger sign that is found on electricity poles or electric transformers and substations. This warning tells us that high voltage current is passing through and we must be careful. Our elders have cautioned us against touching an electric appliance with wet hands. We all should know why it is dangerous to touch an electrical appliance with wet hands. We have learned earlier that the materials which allow electric current to pass through them are good conductors of electricity. We found that metals such as copper and aluminium conduct electricity. On the other hand, materials which do not allow electric current to pass through them easily are poor conductors of electricity. We found that materials such as rubber, plastic, and wood do not conduct electricity. To test whether a liquid allows electric current to pass through it or not, we can use the tester. However, replace the cell by a battery. Also, before using the tester, we should check whether it is working or not. Activity. Join the free ends of the tester together for a moment. This completes the circuit of the tester and the bulb should glow. However, if the bulb does not glow, it means that the tester is not working. The reasons may be loose connection, or the bulb may fuse, or even cells are used up. Check that all the connections are tight. If they are, then replace the bulb with another bulb. Now test if the tester is working or not. If it is still not working, then replace the cells with fresh cells. Now that a tester is working, let us use it to test the various liquids. To test whether a liquid allows electric current to pass through it or not, we can use the tester. Activity: collect a few small plastic or rubber caps of discarded bottles and clean them. Pour 1 teaspoon of lemon juice or vinegar in one cap. Bring your tester over this cap and let the ends of the tester dip into lemon juice or vinegar. Take care that the ends are not more than 1 centimeter apart, but at the same time, do not touch each other. When the liquid between the two ends of the tester allows the electric current to pass, the circuit of the tester becomes complete. The current flows in the circuit and the bulb glows. When the liquid does not allow the electric current to pass, the circuit of the tester is not complete and the bulb does not glow. In the above situations, even though the liquid is conducting, the bulb did not glow. What can be the reason? Due to the heating effect of current, the filament of the bulb gets heated to a very high temperature and it starts glowing. However, if the current through a circuit is too weak, the filament does not get heated sufficiently and it does not glow. And why is the current in the circuit weak? Well, though a material may conduct electricity, it may not conduct it as easily as a metal. As a result, the circuit of the tester may be complete and yet the current through it may be too weak to make the bulb glow. Can we make another tester which can detect a weak current?
You may use an LED in the place of the electric bulb in the tester. LED glows even when a weak electric current flows through it. There are two wires called leads attached to an LED.
One lead is slightly longer than the other. Remember that while connecting to a circuit, the longer lead is always connected to the positive terminal of the battery, and the shorter lead is connected to the negative terminal of the battery. Let us use another effect of an electric current to make another kind of tester. What happens to a compass needle when kept nearby when the current flows in a wire? Even if the current is small, the deflection of the magnetic needle can be seen. Let us make a tester using the magnetic effects of currents. Activity: take the tray from inside a discarded matchbox. Wrap an electric wire a few times around the tray. Place a small compass needle inside it. Now connect one free end of the wire to the terminal of the battery. Leave the other end free. Take another piece of wire and connect it to the other terminal of the battery. Join the free ends of the two wires momentarily. The compass needle should show deflection. Your tester with two free ends of the wire is ready. Take about 2 teaspoonfuls of tap water in a clean and dry plastic or rubber cap of a bottle. Use the tester to test whether the tap water conducts electricity or not. Tap water conducts electricity. Let us now test the conduction of electricity through distilled water. Take about 2 teaspoonfuls of distilled water in a clean and dry plastic or rubber cap of a bottle. Use the tester to test whether distilled water conducts electricity or not. Distilled water does not conduct electricity. Distilled water is free of salts and is a poor conductor of electricity. Now dissolve a pinch of common salt in distilled water and test. When salt is dissolved in distilled water, we obtain salt solution. This is a conductor of electricity. The water that we get from our sources such as taps, hand pumps, wells, ponds is not pure. It may contain several salts dissolved in it. Small amounts of mineral salts are naturally present in it. This water is thus a good conductor of electricity. Small amounts of mineral salts present naturally in water are beneficial for human health. However, These salts make the water conducting. So, we should never handle electrical appliances with wet hands or while standing on a wet floor. We have found that common salt, when dissolved in distilled water, makes it a good conductor. Most liquids that conduct electricity are solutions of acids, bases, and salts. When an electric current flows through a conducting solution, it produces an effect on the solution. Summary: some liquids are good conductors of electricity and some are poor conductors. Most liquids that conduct electricity are solutions of acids, bases, and salts. That is all in this topic, students. Now let us learn about chemical effects of electric current and electroplating in our next topic. Learning is fun.